Hi everyone, and welcome to our video of the law of sines with the two triangle SSA case. So if you're going in order, we've been doing the law of sines where we start them off like this every time. So that's what's at least good about these problems. So you know instantly where to start, and then it just becomes tedious, I would say. So we use the law of sines. It's not the worst thing, but that's how they go. Same deal with this one. Again, we won't know if there's one, two, or no triangles until we just start going at it. So let's set up our table. So we have, whenever we're solving a triangle, I like to set up a table. So we have A, we don't know. B, we've got 25 degrees. C, we don't know. And then little a we'll put to the side here. We don't know. Little b is 60 feet. And then little c is 90 feet. Okay, so we've got that. Let's box it up like we normally do. And then now we'll just instantly set up our law of sines. So we have sine of A over little a equals sine of B over little b equals sine of C over little c. So I like to set that up with the letters, and then now I input whatever those actual numbers are for the ones that I can. So we have sine of capital A over little a, that's useless, equals sine of 25 over 60. Okay, that one's important. And then equals sine of C over 90. Okay, so it looks like in this case, we can start by solving for angle C. So for angle C, we can do the sine of the 25 over 60 equals the sine of C over 90. And then I'm going to multiply both sides by 90. So we'll have 90 sine of 25 degrees over 60 equals sine of C. Now, we'll need a calculator for this anyway, so what I'm going to do is plug that in and get a decimal. So we have 90 sine of 25 divided by 60 is 0.6339. 0.6339 is that sine of C. Okay, and then now we can use our inverse trig property. Okay, so what I've been doing, I've been just saying, well, we could put sine inverse on both sides here. The right side, there we go. And that way the sine inverse and the sine would cancel. We're left with just C on the right. The left side, we can plug that in. Okay, so let's see what that is. All right, so our sine inverse of that last answer, there we are, is 39 point, let's just do one decimal, 39.3 degrees. Okay, and let me cloud it. There we go. Okay, so we have 39.3 degrees for C. Now, when we talked about these, I'm scrolling again. When we had the one triangle case, all we have to do each time when we solve for an angle, we just instantly have to check what's highlighted here. We have to check its supplement, which really just means do 180 minus the angle we just found. And then from there, see if it makes sense if it could make another triangle. Okay, so immediately we could say, well, let's check this out. I call it C star. You could label it however way you want. Is equal to 180 minus C. And so our C star would be 180 minus 39.3 degrees. And then when we do that subtraction, okay, so let me type it in, is 140.7. So C star is 140.7 degrees. And again, I'm going to cloud that. Okay, and then immediately what we do with this angle is see, does it make sense with this other angle that's given, the 25 degrees? Can I get another triangle out of it? And so what we currently have is, let's see, so instantly we say, well, 140.7 plus the given angle, 25, that is equal to 165.7, which is less than 180 degrees. So that means we can find one other angle here to have it equal 180. So that means there is a second triangle. So that's all we have to check. As a reminder, let me scroll. On this one, when we got the second angle, we have it right here. The second angle plus the given angle, which was 70 in that problem, was larger than 180. So that means that cannot make another triangle because it's already bigger than what the maximum sum of the angles can be. This one, though, it's not. Okay, so it's makes it to where we can still squeeze in another angle. So that means we have another triangle. So there's triangle 1 up there. Here's triangle 2. Just setting it up. Everything that was given stays the same. So the angle B we still know. And then we still have B is 60 feet and C is 90 feet. Okay, so we still have that information. What we currently now have, though, okay, I'm going to keep this one in blue. Okay, so I'm gonna say that's the 39.3 degrees for the original triangle, and then now we have a second triangle. Let's do those in purple. 140.7. Okay, and you can even put the little stars on these ones if we want, just to say, oh, those are different A, B's, or A's, capital A, little a, and capital C than what we're going to have from above. Okay, so there we go. So now we're rolling. Okay, so now it really is 2 problems in one. So we have 2 triangles with the given information. All right, well, right away on this first triangle and the second triangle, let's get the missing angle. Remember that all 3 angles need to add up to 180. All right, so we can solve for A plus 25 plus 39.3 degrees equals 180. So I'm just going to go to my calculator and do 180 minus 39.3 minus 25, 115.7. Okay, so there's the missing angle for the first triangle. The second triangle, back to purple, again, the same thing. I'm going to say A star, though, plus the 25, plus the 140.7 degrees, also should add up to 180. So again, I'm just going to subtract 180 minus 140.7 minus 25, 14.3. Like that. Okay. And then now I can set up my law of sines. Again, I'm back to, let me even highlight. This is the original law of sines that got it all going. And we're just going to use that twice to finish this problem. Okay, so still I'm just going to label it triangle 1. So looking at the highlight, I'm going to fill in the angle A, though. So sine of 115.7 degrees over little a equals sine of 25 degrees over 60 equals sine of 39.3 degrees over 90. Okay, so there's just filling everything in again. I really only need little a. I can use these 2 to get it. So I'm just going to set it up as sine of 115.7 degrees over a equals sine of 25 degrees over 60. And then we can cross multiply. So we get 60 sine of 115.7 degrees equals a sine of 25 degrees. And then we'll divide by sine of 25. So we have 60 sine of 115.7 degrees over sine of 25 degrees is little a. And then now I can plug that in. All right, so back to the calculator. So we've got 60 sine of 115.7 divided by sine of 25. And we get 127.9. So we'll do it to 1 decimal. So little a, let's just fill it in, 127.9. Okay, so I use that to get it. Okay, and then now, back to purple, triangle 2. You can see how this is the worst case because it is two problems in one, and these are already long anyway. All right, but we can still set up the same deal. Back to the yellow highlighted. Okay, so back to this and just filling those in. Sine of 14.3 degrees over little a is what we're trying to find, equals sine of 25 degrees over 60 equals sine of c, which is 140.7 in this problem, over 90. Okay, so we can still set those up. All right, well, it pretty much follows the same steps as what we just did in the blue. We would want to set these two equal to each other and then cross multiply. So let's do that in one step. So I'm setting those equal and cross multiplying. So 60 sine of 14.3 degrees is equal to a sine of 25 degrees. And then we'll divide by sine of 25. So we have 60 sine of 14.3 degrees over sine of 25 degrees is little a. Okay, and I'm just clouding it. That's what I need to plug in. Let's get it. So 60 sine of 14.3. Let's just type that over. There we go. And we get 35.1. And now we can put that in, 35.1 feet. Okay. We got it all. We did it. All right, let's double check it a little bit to see if we're at least on the right track. Remember, the biggest angle always matches with the biggest side. So I'm just marking, yeah, biggest angle, that is the biggest side. Smallest angle, small side. Medium angle, medium side. And then with the second triangle, it should also match that. Smallest angle, yep, that's the smallest side. Medium angle, yep, that's the medium side. Largest angle, largest side. Yep, good. Okay, so it matches that. Okay, so these are strange problems because the law of sines is can give these abstract scenarios where we have two triangles possible because of the way that the sine function works. But I mean, either way, it's all of these problems. So if all of them are just setting up that thing, the rule, and then powering through it. Okay, so be patient with these. Okay, and then just remember, if you find an angle, like we did on this problem, we found an angle first, just instantly do the supplement, do 180 minus whatever the found angle was to see if we need to continue with a second triangle or if it's just one. Okay, so that's that. Thanks for watching. If you have questions, please let me know.